Welcome to Harmonic online tutorial. In this simple harmonic motion question, we are told to find the velocity of the end when passing through the equilibrium position, the acceleration at maximum displacement, and the maximum kinetic energy and potential energy of the mass. Now, if a steel bar clamped at one end vibrates with a frequency of 20 Hz and an amplitude of 5 mm at the frame end, where a small mass of 2 grams is tied. Now let us recall that V equals to that the velocity equals to the product of the angular velocity and the square root of the square of amplitude minus the displacement. Now at this point, our x will be what? 0, because at the end passing through the equilibrium position, velocity will be maximum. So because velocity maximum, then displacement will be 0. So we are left with this, which will now give us the square root of a square will give us omega a. And let us recall that the angular velocity will be given as this. All right, plugging in the necessary parameter into this, then V will be 2 times 3.142, which is the value for pi, times 20, the frequency, times the amplitude, which is 5 mm. Converting this to meter, we have to divide by 1000, so that will be 5 divided by 1000. All right, and as such here, 0 will cancel this 0. Okay, now 5 here, 1, 5 here will give us 4. Sorry, will give us 20. 2 here, 1, 2 here will give us 10. Right? Okay. Now 2 here, 1, then 2 here will give us 5. And as such, now 5 here, 1, 5 in 3 impossible, we have our 0. Okay, let us say V here, we have 0. Now in 31, that will be point. In 31 we have 6 remainder 1. Now in 14 here we have 2 remainder 4. Then in 42 here we have 8. Then remainder 2. In 20 we have 5. All right, so this is our velocity. Now what next is to find the acceleration. Now let us recall that acceleration is given as minus omega raised to the power of 2 and r, or x. Oh, sorry, a. Yeah. So now from here, now we know that the value of our amplitude here is given. Okay, we have to input this into the expression. So by so doing, what we just need to do here now is a equals the amplitude here will be 2 pi f all squared, then times the amplitude, which is 5 divided by what? 1000. Okay, so here we have that our a equals that will be 2 times 3.142 times the frequency, that will be 20, or this is the power of 2 times 5 over 1000. Now we have to punch in calculator to get this value, and by punching here we have okay, here we have 79 meter per second square. Okay, all right. So the next one, what we need to do now is to find the maximum kinetic energy. And the maximum kinetic energy, let's see here, is given as 1/2 meter. Sorry, the mass, the velocity, or squared. Okay, now we're given the mass to be, and we need to convert this 2 grams that will be divided by 1000 will give us 0.123002 kilogram. 123. Okay, so now let us input this into this, and our velocity is 0. We can just approximate this one to 0.63. Okay, now let us input these values. So here we have kinetic energy will now give us 1/2 times the mass. That will be 2/1000 times 0.63 all raised to the power of 2. So our kinetic energy, so here we have K E, this one will be, okay, this one here will be 500. This is 1/1000 times 0.63 all raised to the power of 2. Okay, now punching our calculator here, you have this will be, sorry, okay, here you have 3.9 times 10 raised to the power minus 4 joules. Okay, so that is that for the kinetic energy. But for the potential energy at this point, since the potential energy and at this point the velocity is 0, then the potential energy will be 0. Okay, all right, now this is the final answer to this question. And if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics, chemistry, and mathematics. Thank you, and God bless you.